Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday evening. For those of you that are new to Space Oddities, you're especially welcome. We hope you'll stay around and consider subscribing to the channel. And we're a bit light on the ground tonight, folks. I don't know, Tom's missing in action. Lou can't join us this evening because of the time difference at the moment between us and the US. Now is the time when he's starting teaching, so he couldn't be with us today. But once our clocks go forward on the 30th, we'll be back to normal. Hopefully be able to join us. So this evening, as well as the usual reprobates of Roger and Michael, we're joined this evening. We're very, very happy to have with us Mr. Gurbir Singh, who's going to be talking to us about the Indian space program. And we're really excited to hear about that because it's something that we do follow on Space Oddities. And Gurbir knows a lot about it, so we're going to hand it over to him. Good evening, Gurbir. How are you?
Very well indeed. Nice to be here. Thank you very much for the invite.
Well, thank you for being here. Okay, so first of all, we'd like to apologize again for the very jerky video for the first third of last week's show. I've taken that up with our streaming provider, and it happened because one of their servers was overloaded, and that's why we had a jerky video. So apologies for that, but you know, as we said last week, it was completely beyond our control. Nothing we can do. So we hope he didn't spoil your enjoyment too much, but I think we appear to be okay this week. And you know, I asked the streaming provider to tell us that it wouldn't happen again, but of course they couldn't. So we just have to play it by ear. So we hope you've all had a great week. It's been a week of heavy rain again here in Spain. This has been the wettest spring I can remember in my 20 years of being here in Spain. And it's just gone absolutely crazy. But we had a lovely day today, a lovely warm sunny day, but the heavy rain's coming back tomorrow. In fact, we've got a yellow warning for rain as of midnight tomorrow. So that'll be great for the weekend. And there we are. So let's just see who we've got in the chat. Let's have a look. Jerry's here, Ian's here, and a few others. So welcome, guys. And don't forget, if you would like to support Space Oddities, then we have a way of you for doing that. You can buy us a coffee in the Buy Us a Coffee website, and all the donations are gratefully received, and everything goes towards keeping the channel ticking over, as it were. So you can scan the QR code, or you can click the link that's just appeared in the chat. Don't forget, we still have the Space Oddities shop, where you can buy your Space Oddities merchandise. That is to say, t-shirts and hoodies, all at very reasonable prices and very high quality stuff indeed. And as we keep saying, we hope to expand the range of merchandise soon. So we'll let you know when that happens. What else have we got for you tonight? Well, apart from Gurbir talking about the Indian space program, we've usually got the gallery. We've had a few in for the gallery. If you had taken any images of the eclipse last week, then please send them in to the gallery. But we'll talk more about that a bit later. We've got the return of Einstein of the Week as well. So I'm looking forward to showing you the complete lunacy that I've noticed on social media this week. There's one thing you can guarantee: in any week, it'll be full of absolute lunacy. So we'll have a bit of a fun time looking at the Einstein of the Week. Next week we'll do the same, obviously, and we hope to continue the Einstein of the Week. If you see anything on social media, not just about astronomy, but any aspect of science that you can't quite believe and that gives you a laugh or makes you really feel desperate, then take a screenshot of it and send it to info@SpaceOddities.space, and we'll feature it on Einstein of the Week. So right now, what we're going to do is go over to Gurbir, and we're going to look at India in space. So there we are, Gurbir. The floor is yours, sir.
Well, thank you very much indeed. So I'll start off with just giving you a big picture. It's not going to be like a traditional webinar or a lecture. It's going to be, I'm going to try to imitate what you guys do.
Oh, which is, no, don't do that. Don't do that. Whatever you do, don't do that.
I enjoy myself as I go through these few slides. I don't have that many. And so we'll flip through quite a few very, very quickly. I know there is the traditional Q&A at the end, but if you do have any questions, feel free to interrupt. It won't be an interruption at all. Sometimes it's easier to ask a question right there and then rather than wait to the end. And if you do wait at the end, there should be some slide numbers at the bottom of each slide. Make a note of that, and if it's at the end, I can come back to that slide and we can take it from there. So I'm going to talk about the Indian space program and do it in about 3 sections. So a bit like a past, present, and future. I just want to give you an idea of how India got to where it is today, and that's in a broader sense, not just space, but science and technology. And in India's case, because it was only in 1947 it became independent, science and technology and space has had quite a significant role in the nation building that the Indian government undertook soon as it became independent. Quite an interesting story, very unusual, certainly. And then just talk to you about the stuff that you probably at least have some insight into. If it's not a topic you come to visit frequently, I hope we will remind you of some of the places, some of the people, and some of the events that have taken place that have brought India as one of the big players now with a substantial space infrastructure. And then I want to finish off with a few things about what the Indian Space Program, ISRO, Indian Space Research Organization, has announced that it's going to do. Specifically, I hope I can finish with the India's Gaganyaan program, which is the human spaceflight program, and that will lead us hopefully into Crew 9 returning in about a couple of hours, splashdown, I believe. So that's the plan. And next slide, please.
Certainly, sir.
So some links there for me if you'd like to, some of my books I've written. Next slide, please. Okay, I do want to leave you with some resources, and these are resources that I used when I was writing my book. My book, I should have mentioned, the Indian Space Program was published in 2017. It was the end product of a 5-year research activity. I was working full-time at the time. I have now retired, but at the time it took 5 years. It required 3 research trips to India. I visited some of the ISRO centers. I visited the ISRO headquarters in Bangalore each time. And some of the sources that I used then, and there are now even more productive and useful resources, I draw your attention to some links on the screen. I don't know if you use Reddit, but really the subreddit ISRO is something that is pretty much up to date. It's comprehensive, and it's been going for such a long time. There's a lot of history there as well. That is the top resource I would recommend if anybody's interested in following what's going on now and in the recent past as well.
Yeah, I keep seeing bits and pieces from Reddit. I must admit, I've never used it. Perhaps I should take a closer look, but thank you for the address. I will definitely check that out.
And that bit of the image you can see on the bottom right-hand corner with all the links, official links, that's from the ISRO Reddit page, and it gives you links to the individual ISRO centers. So it's really handy. Wow. Yeah, well, actually, this isn't comprehensive. These are the primary ones. There's many more centers, but it does give you all the links in one place, and they usually up to date. I should mention, though, ISRO being a government agency, the ISRO website, isro.gov.in, and indeed many of its links that to the centres, which are managed by ISRO, do frequently just go offline and then mysteriously come back on again.
Really?
So just be aware. The change control that ISRO website experiences not the sort of change control that we used to. There's another guy, quite a young writer, who's been writing about space generally, but also writes about the Indian space program. Jatan.space is his website. He writes some very useful and informative stories from India and about the moon and many other things to do with space. And he's somebody that I think you should follow, keep an eye on, and subscribe to some of his mailing lists. And
Great.
PladX is also, and both of these guys are independent editorially. They are based in India, in Bangalore, I think both of them. And then there's a podcast, New Space India.transistor.fm, which has a lot of programs about the Indian space program from people who worked in there, particularly the historical side. And the information you'll see on the slides I'm going to be sharing with you comes from a couple of documents that ISRO publishes. One is the annual report, and it's published by the Department of Space. That's the government department under which ISRO operates, and they produce this report every year. So some of the statistics and graphs I'll share with you later on come from that book, from that report, and they're available publicly.
Great, thank you.
And the next slide, please. So, as you know, India is one of the ancient civilizations, been around for centuries, and it's no surprise, therefore, that the tradition of science is embedded very deep in its history, just like we've had here in Europe. Science was intermingled with religion and faith, and the church and religious authorities were really where the science came from until the Enlightenment here in Europe, and likewise in India. There's a lot of connection between astrology and astronomy. And you might have been to India and seen structures like this, called Jantar Mantar. Now, they look really old, but they're not. They're only about 150, 200 years old. There's at least three in India: New Delhi, Jaipur, and one other place which I've forgotten. And they are operating astronomical instruments. And if you've been to Mongolia, you're probably familiar with the Ulaanbaatar, where the original older versions of these are still there, or remnants of them at least. So there's a long tradition. Next slide, please. And I want to share with you a book that came out recently. I won't spend much time on here, but this book was only published last year. It's called The Golden Road, and it's called The Golden Road, really developing the idea of the Silk Road. And it's not really a road. As you can see in the dotted lines in the map, most of it is ships or sailing lanes in the Indian Ocean. And the historian, I think most of you will be familiar with the name William Dalrymple if you're into Indian history. He's originally from Scotland, but he's been living in India for quite a few years. And this book really lays out some of the long history of connections that India's built in science and technology. And surprising that things like mathematical number zero, the idea of eclipses coming from instruments that we saw on the last slide, were just like we did here in Europe, also considered to be having been calculated and determined scientifically through experiment a couple of thousand years ago. And in this book, William Dalrymple is saying that in the same way that when I was going through education here in England, I learned about the Roman Empire and the Greeks and how there was a great big network, particularly here in England, where Romans conquered England for many centuries. India, during the first millennia, pretty much, had this huge trading network, the Golden Road, and there's this thing called the Indosphere, just like the Greek or Greco-Roman world that we're familiar with. And so India had a much larger presence in the Southeastern Asia than it does today. And apparently a lot of the gold from the Roman Empire ended up in India. That's the other reason why it's called the Golden Road, because there was so much trading taking place between Europe and India in those times. The Golden Road by William Dalrymple is really worthwhile. There's a lot more science in there than I've touched on. Next slide, please. So, because India was occupied for about a couple of 100 years, so in fact, the very first ships that went to India initially as to establish trading routes arrived in India about the same time that Galileo was turning the telescope to the heavens, about 1608. And so there's a long tradition of, because of colonization, of what we experienced in the Enlightenment and the Industrial Revolution, of science and technology going from Europe to India. Now, it was a colonization, it was exploitative, but there was this direct transition or transfer of technology from Europe to India because of that. And let's mention a couple of things, a few people. So there's this guy called Jagdish Chandra Bose, and he did some pioneering work with radio, along with many other things. In 1895, in April, he did a demonstration for the Royal Society in London, where he demonstrated the idea of what we today call a diode. And that was an essential element in the development of radio. And he developed something called the self-recovering coherer. A coherer is what he called the diode, or performs the modulation and demodulation element in radio receivers and transmitters. Ramanujan, I don't know if you're familiar with this film called The Man Who Knew Infinity. Came out a few years ago, and he was one of these savants, so incredibly capable mathematically, socially inept at pretty much everything else. But he did spend about 4 years of during the World War I in Cambridge, and during that time he did some remarkable work in maths, in number theory, infinite series, and continued fractions. And some of that work is still being used and deployed around in the field of maths today. Don't know if you are familiar with the Sherlock instrument, which is on board the I forgot the name of the probe on.
Oh yes, you mean.
There's a probe from NASA, 1-ton probe operating on Mars right now. One of its payloads called Sherlock, which is the scanning habitable environmental with Raman and luminescence of organic chemicals. And
that's on the Perseverance rover.
Yeah.
Thank you very much. Percy is what I was going to think of. The Perseverance rover. Thank you very much. And that's technology using the discovery that C.V. Raman made in 1929, for which he got the Nobel Prize for Physics. And C.V. Raman, is really still idolized in India. In fact, in January 28th, I think, is officially a Science Day in India in memory of that discovery then.
All right.
And then there's another guy called S.N. Bose. If you've heard of baryons and bosons and hadrons, bosons comes from his name, S.N. Bose. And he worked in quantum physics, and he worked with Einstein in the mid-1920s. In fact, you know, the special relativity came out in 1905, and it was in 1915 when the general theory of relativity was published by Einstein. I'm gonna, I said you could ask me some questions. I'm going to ask you some questions, but you don't have to answer them. When do you think the very first version of the general theory of relativity was published, and where in English?
Ooh, that's a good question.
Yeah.
I'm guessing, well, obviously it would have been before 1915.
After, yeah. Mm-hmm.
Yeah. Sorry, after, yeah. But I've no idea where.
Well, it was published in Calcutta. And along with S.N. Bose, there's another guy called Saha. And the reason I mention that is because he, S.N. Bose, wrote to Einstein saying, hey, look, can we publish this or translate and publish your general theory of relativity, which was in German. So the S.N. Bose not only spoke German, but he also spoke and understood French as well. And he, along with help of a couple of other guys, translated and published it in English. And that was in 1924, if I remember correctly.
Right.
And no, actually, it was a couple of years earlier than that, because in 1924, S.N. Bose wrote to Einstein, and he said, look, I've written this piece of mathematical work, and I would like you to publish it in German. There was this well-known publication called the Zeitschrift for Physics, and it was the going I'm guessing like the Scientific America or New Scientist of the time. And he, S.N. Bose, said, look, I can read and write, but I need somebody to translate this into German, because my writing, the original material in German, is not all that great. So can you, Mr. Einstein, please translate this into German and then publish it in Zeitschrift for Physics? Einstein saw this piece of this piece of work, and it's just as well. So he saw it. He said, "Yep, that looks really good. I will translate and publish it," and it was published. And as a result of that, S.N. Bose got a paid leave from India, and he traveled to Europe and worked with Marie Curie in Paris and Einstein in Germany, and he did a really, really good time. So Einstein was just the right person to receive this, because pretty much a handful of people would have been able to understand what S.N. Bose had written, because what he'd written was something that would eventually lead to something called a new state of matter, a Bose-Einstein condensate state, which wasn't really made for the first time until the 1990s. So very profound piece of work.
Wow.
Timely that he sent it to Einstein, because hardly anybody else would have really understood that. Okay, next slide, please. So in addition to some fundamental work in maths and science, there was this very high-level practical work, which meant setting up, astronomical observatories. Today, we know that the best places to set up astronomical observatories, optical astronomical observatories, is on tops of mountains, because you get above all of the cloud, and indeed most of the dense, lot of the dense part of the atmosphere. And so seeing conditions are generally much better. But that didn't really happen until the 1790s. The Madras Observatory, the one at the top, and a century later, the Kodaikanal Observatory, which later became a solar observatory, were all network observatories throughout India, which were really designed to, as well as do genuine astronomical scientific work, but also predominantly to collect data about weather information. And that was very important, because most of the navies, including the British Navy, on which the colonization of India relied, involved sailing to and from, which was a matter of life and death. And having better insight into how the monsoon winds worked was critical part of that information. So these observatories, for legitimate reasons, were placed in locations that solved the need that all of us would recognize, astronomical, but also there was this underlying need for the commercial imperative that also existed. The Lucknow Observatory was unusual in that it was funded directly by a wealthy Indian. Oud is a place, and the Nawab was the local leader, and he provided the funding. So unlike Madras and Dehradun and Kodaikanal, it was an observatory funded by an Indian. Got another pop question for you. It's literally a pop question. Lucknow. Which British pop singer, pop legend was born in Lucknow? Anybody know?
Oh, gosh. Cliff Richard.
Well done. 10 marks.
Thank you.
Excuse me 1 second. Okay. Just leave it there. It's fine. The Great Trigonometrical Survey, TGS, is another aspect of science and technology being used in a setting. The picture you see in the bottom right-hand corner, it's not very big, not very clear, but essentially it's what most surveyors do with these surveying instruments. And what the role of that was for Britain was to really identify where and what the natural resources were in India. And that took ages to conduct, and it identified the coal, petroleum, and gold. And in 1852, the GTS revealed that the highest mountain was also in India, and it was promptly named after the governor at the time, Mr. Everest. That's why it came.
Ah, I never knew that. Wow. That's interesting. That's a good pop quiz question.
Oh, yeah, definitely.
Okay, Okay, I think, yeah. Okay, yeah, if I go on to the next slide, please.
Yeah, sure.
So just some names I want to mention. I'm going to speed up a bit, actually. I'm do feel free to ask questions if you want in the chat, and I'm happy to take them, as I was saying earlier. So Jawaharlal Nehru, the guy in the bottom left-hand corner, you might recognize as the first Prime Minister of the independent India in 1947. Although he looks and always dressed in this traditional Hindu dressing garb, but he really wasn't all that religious. He was, in fact, a man of science, so much so that he ensured that science was written into the Indian Constitution, which was published a couple of years after independence. And he drove the whole policy of India of developing a new nation, that it should be founded on science and technology. Some of you, are old as I am, might remember the white heat of technology statement from Harold Wilson in the 1960s in England. There was this genuine desire to make use of the then new technologies to make sure that the economic future of that nation was sound. And that's what Jawaharlal Nehru did as well. Vikram Sarabhai, he's the guy on the bottom right. He's considered to be the founder of the father of the Indian space program. And he, just to get a Manchester connection in there, he started studying his PhD in Cambridge in 1939, but when the war broke out, his parents said, "Come back home, they're all fighting in Europe, we don't want you there." So he went back and studied in Bangalore under C.V. Raman, who would by then a very well-known figure in India and indeed around the world because of his Nobel Prize. So he's continued his PhD in cosmic ray physics, and by the end of after the war, he completed his PhD, and he came to Manchester to complete his viva, because the original, the displacement after the World War II was quite severe, and many people, of course, from Cambridge didn't survive the war. So in order to do his viva, he came to Manchester, and the examiner was the guy on the top left, Patrick Blackett. Patrick Blackett plays an important role in India's future, because Patrick Blackett was somebody who had an astonishing career throughout First World War and during Second World War. He was working alongside Churchill and did many of the secret programs. And he was based in Manchester just after the war. And he's the same guy. I'm going to mention another film now. I don't know if you saw Oppenheimer, a film last year or the year before.
Yeah.
Right at the beginning of the film, there's a scene where Oppenheimer, young Oppenheimer, tries to poison through an apple his professor. And that professor was Patrick Blackett. Of course, he survived. But and after the war, in addition to having a huge legacy here in Manchester and throughout World War II, Nehru appointed Blackett as a science advisor in the new Indian government. So he had a lot of connections to India as well. Okay. If I have the next slide, I'll just move on to the next phase of the of this presentation. So this is just giving you a flavor. There's a lot more detail, but just to give you an idea of what India's present space capabilities are. Two pictures you're looking at, well, three. The logo there of ISRO, it looks very Star Trek-y to me. And, if you look at the the picture on the top right, that's the Mission Control Center in Sriharikota, which is where all the spacecraft that have gone to Earth orbit or beyond have taken off from. That's the very modern-looking space saucer type shaped Mission Control Center based in Sriharikota. It was opened in 2012, so just over a decade ago. And the other picture is below that is Professor U.R. Rao, fascinating guy. If there's one guy that I found really helpful doing my research, it was him. By the time I started doing my research for the book, he had retired. He had been the chairman of ISRO for about 10 years, very long stint. And he was appointed by Vikram Sarabhai. He was indeed a student of Sarabhai's, but he went to NASA, and in the late 1960s and early 1970s, he worked in NASA on the various payloads for the Pioneer and Voyager space probes. So he had a lot of insight into building satellites and operating them. And then when the offer came from Russia, the USSR, in 1970, that Russia would launch a satellite that India could build, then it was Sarabhai gave that task to U.R. Rao to say, go away and build a satellite, then take it to Russia and let them launch it for you. And that's where the very first satellite that India built came from. And U.R. Rao was the guy who really led that. And it's terrific accomplishment. A very nice guy, very helpful. And I was two things he told me, which are sort of anecdotes, really. In November 1963, he was waiting to meet JF Kennedy in Dallas. And if he had not been shot a few hours earlier, he would have been shaking his hand. He was a very prominent figure, or reasonably prominent figure in NASA. And he said, oh yeah, I was waiting to meet President Kennedy when Kennedy was shot. The other interesting thing that he told me about, Arthur C. Clarke is the guy behind the extraterrestrial relays paper, this idea of you have 3 satellites, a geosynchronous orbit, and then you have global communication. Arthur C. Clarke, by 1975, was living in Sri Lanka. And at the same time, when India engaged in a bit of collaboration with NASA, sharing a communication satellite, using satellite TV to bring education to small villages around India. It was a trial of seeing how you could get education distributed to areas that otherwise wouldn't get kind of education. And he told me that because Arthur C. Clarke was in Sri Lanka, and because Sri Lanka was within the footprint of the ATS-6, this NASA geosynchronous satellite, which was being used for this satellite instructional television experiment or site, that ISRO offered Clarke a dish, a communication satellite dish. It's the kind of thing that you guys have, most of us have now outside our house for satellite TV. But Arthur C. Clarke was one of the first private individuals to have a satellite dish on his private property, which was, I thought, an interesting coincidence.
Wow. I think I've seen a photo of that actually somewhere. I'm sure.
Yeah, you probably have. The satellites were, the satellite dishes were pretty much handmade. They're designed to be made quite easily and cheaply. We're using chicken mesh because the wavelength was a few centimeters and you could easily build it by hand manually.
Wow.
Okay, next slide, please. So just some more people. The other person I wanted to mention that you see is in the first picture. There's Vikram Sarabhai on the left, but on the right, it's a guy called Homi Bhabha. And Homi Bhabha was about 10 years older than Vikram Sarabhai. And actually, it was Homi Bhabha who was the primary contact, who was an atomic physicist. He'd worked in Cambridge at that golden age of atomic physics in the 1930s. And then he, in fact, got a job to teach in Manchester for Patrick Blackett in 1939. And he was due to start in September of 1939. But before starting, he thought he'd go home to India. And then before he could come back, World War II started. So he never came back. And in the instead, he was convinced by Nehru to stay in India and build what's now known as the Tata Institute for Fundamental Research. It's just on the outskirts of Mumbai, or Bombay, and it's one of the places I visited for my research. And Homi Bhabha, because of his contacts, he also had really good contact with Paul Dirac, Heisenberg, and of course Einstein. So he was able to use his insights and his intellect to develop one of the elements of research institutions, which he was promised, and he did, and it still exists today. But in 1966, he was coming to a conference in Switzerland, and unfortunately the aircraft crashed into the Alps, and he was killed. And then Sarabhai took over both the role in space as well as the Atomic Energy Commission that Bhabha had been in charge of. The very small, undecipherable image you can see to the right is a bag, which you can't see the writing on, but it says diplomatic mail. And that was something that was recovered. The plane crash and his death was in 1966. And the receding glaciers revealed this diplomatic bag from Bhabha that he was carrying on board with him in 2012. That was quite a relatively recent discovery. You're probably familiar with the X-ray telescope in orbit right now called Chandra. That's named after Subramanian Chandrasekhar. That's the picture on the right-hand side. And he came to Cambridge in the 1930s, and then went to Chicago, was working there. And he almost started to work on the Manhattan Project, but his clearance came through too late, and he never quite made it. But in 1966, when the Indian government was in a bit of a panic, when Bhabha died as a result of this sudden crash, they contacted Subramanian Chandrasekhar and said, look, can you come to India and take over his role? And he said, this is the Indian Prime Minister asking him. And he said, look, yes, madam, I'd like to do that, but I can't. I'm no longer an Indian citizen, but a USA citizen. So he couldn't. And then Sarabhai took over instead.
May I just butt in at this point? If you'd like to know more about the life of Chandrasekhar, viewers, have a look on our channel. There's a video all about his life that we did to celebrate the great man. So that's on the channel.
Well, thank you for that. I've not seen that, so I will make a note of watching that. Thank you.
Okay.
The other guy I don't have a picture of is a guy called Satish Dhawan. And Satish Dhawan was the guy who took over from Vikram Sarabhai when Vikram Sarabhai died rather suddenly in 1971. And if you might hear that name, the Satish Dhawan Space Center, which is also the same place, Sriharikota, but it's named after the Satish Dhawan, who took over as the chairman of ISRO actually took over about a year later because he had commitments teaching commitments in the US. But Satish Dhawan was also somebody who did remarkable work in making ISRO, particularly in the development of the liquid propulsion engines, which is something that took place in the 1970s with the aid of help from France. Very briefly, 1962, in COSPA, Indian COSPA, Committee on Space Research, is the year that it was founded as a government body, and it was in 1963 the very first rocket to go into space was launched from India. It was an American Nike Apache rocket, suborbital, but in 1963 is what I think of as the starting point for the Indian space program, although ISRO itself was founded in 1969, and then this is all governmental stuff. The Department of Space, under which ISRO operates, was established in 1972. It's just a little bit of administrative stuff there that probably isn't all that fascinating. Great. Okay. Next slide, please. Just show you what the Indian space services are that Indian population receives from space, what the value is for Indians, ordinary Indians, in having ISRO. ISRO is very unusual in that amongst all the countries that have a space program, India is the only one that started out in a non-military purpose. Yes, India has military satellites now. It's conducted an ASAT test. It does science programs, and it does commercial satellite launches. And soon it's going to be moving into human space flight. But that's not what it started off as. It's unique in that it's designed for development of the local economy of nation building. That's what was the initial goal. So today, there's a lot of communication satellites. You'll hear names like INSAT and GSAT, Indian satellite and geosynchronous satellites. And they provide a lot of the direct-to-home TV that is very popular in India, as indeed is elsewhere, but also a lot of the businesses. Like these days, newspapers in the old days used to print papers from one place and then take them across the country to another. Now the images are transferred by satellite, very high speed, and printed locally. Likewise with many other industries, the film industry, hardly anybody uses film these days. Digital films are, digital projectors are used in cinemas, and and the whole film is transferred digitally from one place to another as well. India is a huge place. Its space assets are used to surface image the surface, sea, atmosphere, natural resources, disaster management. There is a whole fishing industry that relies on information from space. The GPS, they call it Indian GPS, but it's actually not a global positioning system, but a regional one. And it's called NAVIC, and it's very limited. I think now there are about 7 or 8 satellites that provide the navigational signal, and it of course has the military component to it as well. Weather satellites, India is well known for cyclones and the disasters that follow. It's not only early warning systems, but also post disaster recovery that satellite imagery is really useful for as well. You may have heard of something called COSPA SARSAT. It's something that was set up back in the 1970s by Russia and Canada, but now it's global, and India plays a role in that. It's a service which is provided by usually multiple satellites, low Earth orbit and geosynchronous, and all they are transponders which initiate and listen out for signals on a particular frequency. So you can take a handset with you, and if you do find yourself stuck, press the emergency button and it will send out a signal of your location, and then that signal is passed to a local rescue station near to where you are, and that initiates a recovery. These days, hopefully in the next few years, we won't need that because most mobile phones will have the same capability, probably. India also operates something called the GPS augmented navigation, satellite-based augmentation system, SBAS. India has one, USA, Canada, and Japan. And these are really the kind of things you have in your car for GPS navigation, but for civil aviation. They're working to very high precision, safety of life criteria, and any aircraft coming into Indian airspace will make use of that kind of technology. It's something that's going to go around, hopefully, around the world before too long. There are satellites that Israel's launched for the Indian Navy, Indian Army, and air services as well. And we know about, and I'll talk briefly about the missions to the Moon and Mars and the Space Telescope in, I was going to say in Earth orbit, but it's not in Earth orbit, it's at Lagrangian point L1. Okay, next slide, please.
Certainly.
Very briefly, these are the launchers that India operates. The SLV-3 and the ASLV were really no longer operational. They were used at the outset. They've been out of service for a very long time. SSLV, this is the satellite launch vehicle, SLV, satellite launch vehicle, PSLV, polar satellite launch vehicle, GSLV, geosynchronous launch vehicle, and LVM-3 is large. No, it's not large, but these are terms that I've come across, and they keep changing them. But essentially, today, PSLV, GSLV, and the LVM-3 are the three operational launchers that India has. By and large, it's the PSLV. The GSLV has, and the LVM-3 have a cryogenic option, third stage, but the real problem with India with the launch vehicle is that everything takes ages, and up until recently, everything was built by Israel. It's a bit like NASA building all the launch vehicles. It's just not practical. It outsources most of the launch services. In fact, most of NASA's work is now outsourced. And that's the case that India is moving towards right now. And I think that's the reason why India doesn't launch very often. The cadence is about 6 or 7 per year. And I think 7 is the highest. And it's the latest, the newest one is something which I think I had hoped would increase the facility, the launch cadence, but it hasn't done so really. There's a new launch port being developed to make use of the new single solid fuel rocket launcher, the SSLV. I thought that would pick up cadence, but so far it's very, very slow. But the LVM-3 has been human rated as well, and that's going to be a necessary component for human spaceflight, as we shall see shortly. Next slide, please. One of the reasons why, to get a flavor of why India doesn't have such a large infrastructure in terms of launchers and launching ports. China, for example, has 4 launch ports. I think Japan has at least 2 with multiple launch capabilities. And India doesn't because of budget. I won't go through all the figures here, but the two key things to bear in mind is that any nation, includes India, two characteristics determine what kind of infrastructure it can have. One is a level of political commitment that a government makes to its space program, and the other is the economy, the status of its economy. As you've probably noticed in the last decade or two, especially last 2 decades, Chinese economy has grown incredibly well. And as a result, they can fund the increasingly large portfolio of space missions that they're undertaking. And why India doesn't do that to that extent is because the funding is very minimal.
That's not a lot of money, is it really, compared to the others?
Just repeat that.
I said it's a tiny amount of money compared to the others, isn't it?
And that explains, I've just whinged and complained about India not launching often enough, but that's why. And it's India's budget. NASA is 25 billion. India's been between 1 and 2 for the last few years, and it's set aside in 2018 when the Gaganyaan mission, this is the human spaceflight program, was announced, and that from beginning to the completion of the very first human spaceflight was then planned for 5 years. That also had a budget of about $1 billion. So these are huge sums, and that's why I'll get my complaint over and done with now. I wish that India had not chosen human spaceflight at this juncture. I think later on it would have been better, because the money that's going to go on to human spaceflight is something that would have been far better spent in so many of the other areas. There's a list, there's a statista.com where this information came from, but just move on to the next slide, please.
Sure.
And this is the human spaceflight, including some of the other ambitions. It's the final section, not very many more slides to go. What you see there on the left is a capsule sort of design for the human spaceflight. And on the right, you see something that was announced recently. It's India's space station. I want to jump into some of these projects now. Next slide, please. So India has had some people in space. In 1984, Rakesh Sharma spent just over a week. It's the same place that Helen Sharman a few years later went and spent, again, just over a week. And he is still around. He's been helping with some element of the astronaut training. And that's Rakesh Sharma in the top left-hand side. And on the right was his backup, Ravish Malhotra. I met and interviewed Rakesh Sharma for my book. It's a whole chapter of him. And although I spoke to Ravish Malhotra on the phone and by email, I didn't actually get to meet him. 2 guys below, NC Bhatt and Radhakrishnan, they trained to go to space on the space shuttle. And they plan to go in November 1986, and all was going really well until January of 1986, that you'll remember the Challenger accident. And as a result, President Reagan cancelled all the commercial side of NASA's operations with the space shuttle, and they got some training, sort of high-level training in fighter aircraft and astronaut training, but their mission never happened. Kalpana Chawla Indian origin, but naturalized American citizen, and Sunita Williams, who's Indian origin. Her father was Indian, but she was born in the US, and hopefully fairly soon she's coming back, splashing down in about an hour's time.
Yeah.
And yeah, so the thing I'd like to talk about next is the Gaganyaan mission, which was announced by the Indian Prime Minister in 2018, and he announced it and set Israel a goal of 5 years, which would have been the 75th anniversary of Indian independence in 2023, but COVID and many other things just delayed that, and they're still quite far behind the schedule. Okay, next slide, please. So just a flavor of what is planned. Some of the pad abort test and launch abort tests, along with two flights that have already been conducted. In 2007, the very first time that India put something into space and then brought it back down again was a mission that helped set some of the mission parameters and confirmed that they could deorbit, navigate and deploy parachutes and recover the spacecraft from the Indian Ocean. That happened in 2007. And in 2014, similar sort of thing, but in a suborbital flight. So this idea of recovering spacecraft from space is something that's not new. Again, I suspect just the immense cost that these things come with, that it hasn't moved as quickly as it should have done. However, when the time comes, the plan is to conduct 3 uncrewed test flights, just like Yuri Gagarin. I think the USSR conducted 5 uncrewed flights with escalating complexity of spacecraft. Some of them will have the subsystems for life support and environmental control, but in each cycle, the re-entry, thermal control, and parachute deployment, splashdown, and crew recovery will be tested and rehearsed. And after 3 flights, the idea is that there will be a 2-man crew going to low Earth orbit for about a day. It's very unclear. I've seen figures for 3-man crew for a week, but I suspect they will probably go for two men, and there will be two men. There aren't any women in the candidates list. 4 candidates have been identified. They have been trained in the Yuri Gagarin Cosmonaut Training Center in Moscow. They have had some training in the US as well. France has provided some support from a space medicine perspective. Russia has provided some support with the environmental control systems. Most of the capsule structure is pretty much the Russian design. But hopefully, before the end of next year, they hope that there will be a ability to conduct the very first human space flight of an Indian astronaut using an Indian launch vehicle launched from India. One element that they haven't really been speaking much about are these TDRIS satellites. These are the tracking and data relay satellites. In most space missions, you need some level of ground support, ground stations. And when you've got humans in space, you always need access to communication all the time. So the tracking and data communication services are in orbit, and India has yet to deploy TDRIS satellites, which I think is a prerequisite for the Gaganyaan mission. So lots to do, but lots has been done, and fingers crossed, before the end of next year. Next slide, please. So, very briefly, science missions. India's been working on a NASA spacecraft using, for Earth observation, synthetic aperture radar spacecraft. It's got a huge antenna. It should have gone up last year. Still hasn't. Still in India. Will be launched from India, but it hasn't. Just fallen behind. Chandrayaan-3, you'll remember from last year, huge success, very successful mission, landed on the lunar surface. Chandrayaan-4 is pretty much similar, but a sample return. And one of the missions that took place recently from India is called the SpaceOddities mission, which was a space docking experiment where 2 spacecraft docked in Earth orbit and undocked again. The intention being that this will provide the basic experience for the docking and undocking that's necessary for a sample return from lunar orbit. Chandrayaan-5, it's a collaboration with Japan called LUPEX, and it's, again, like most space lunar missions, lunar landers are going to be looking at water deposits, where they are and how easy it is to get to them. India also announced recently the Shukrayaan mission. It's a Venus orbiter mission, and there are contributions, payloads from Sweden, Germany, and Russia. Don't have a date for that just yet. Next slide, please. So, as a part of the recent announcements, there's this thing called Space Vision 47. Keep an eye out for that phrase. You'll see it frequently. 47 is the centenary of Indian independence. And by the way, 2049, 2 years after, is the centenary of the People's Liberation Army, the founding of the state of China. And they're going to be doing something big. That's their goals. These anniversaries are surprisingly strong motivators for getting things done. So as part of that Space Vision 2047, Bharatiya Antarikshya Station, this space station, modular design, is supposed to be up and operating by then. But the initial module should be up there by 2035, and it's supposed to hold 2 or 4 astronauts for a few months. It's also got a funding of just over $1 billion, which is, if you remember, approximately what the whole of Israel's budget is annually. Next slide, please. You remember, if you're all old as I am, you remember the Gemini, Vostok, Soyuz, Apollo race between USA and USSR. Well, the same sort of thing is happening in India and China. And I want to just share with you this thought that whatever India does is usually direct response to what China has announced it's going to do. And I'm going to illustrate that with this list in black text on the right-hand side. In 2007, China announced the first lunar mission, Chang'e-1. And then 2008, India did likewise with Chandrayaan-1. In 2010, China launched Chang'e-2, and then 3 and 4 in 2013 and 18. And then 2019, Chandrayaan-2, which is partially successful. But as you know, Chang'e-5 in 2020, sample return. Chandrayaan-3 last year and Chang'e-6 last year, which was a sample returned from the far side of the moon. So I'm hoping what you can see there is, apart from the fact that China's done a lot more because they planned so far in advance, and they usually stick to their timelines. They're funded because they have a central one-party system. There are no elections. There's hardly any competition. And they've got a lot more money to throw at this. But the driving factor is that China, its potential adversary, I don't know if that's the right term, but that's its challenger. And what India is forced to do, so unless you do that, you fall behind, and you don't want to be seen falling behind. So just a couple more slides. Next slide, please. And then I want to. So one of the big changes, and I think this is where the things that will be happening in the next year and the year to come, will come from the commercial space sector. The figures I have are not up to date, but I meet some of these guys from companies that are developing propulsion modules in space, ion thrusters, as well as rocket launchers from the Earth's surface. And indeed, a rocket. Israel has been asked to support these fledgling startups, and there have been launches from Indian private sector launch companies from Sriharikota. It's still very early days, but there are companies that make satellites. Dhruva Space, it's a huge company based in Hyderabad. International, they don't build satellites just for India, but anybody who wants them. Pixel is developing some hyperspectral Earth observation satellites, and launch vehicles from Agnikol and Skyroot. They are ones I see at international space conferences. They're doing really well. And the picture on the bottom left-hand side, you see the previous ISRO chairman with the Bellatrix CEO, and I think it's the COO. So there is a lot of development. It's still early days, but I suspect that's where the necessary acceleration that India requires will come from. Next slide, please. India's, like many other countries, make use of international cooperation to get going, to kickstart their space program. And India's been really good at doing that, in making use of both support from during the Cold War days, from the USSR and the USA and France, and also the United Nations. Russia, there was a conference last week, despite all the isolation that Russia's experienced as a result of sanctions. India has not really engaged in all that many sanctions against Russia, because traditionally India and Russia have worked really very closely together. I said that the very first Indian-built satellite to go into Earth orbit was launched by the USSR. Rakesh Sharma went to space on a Russian space station, Salyut 7. So it's very strong relationship. It's still live, and India has always done this. They look after their interests rather than any other. I suppose all countries do this. They look after their national interests. India mentioned Indira Gandhi, who was the daughter of Nehru, and she and Vikram Sarabhai both spoke really good French. There are very strong connections culturally and linguistically with France. I mentioned the very first rocket launch in 1963. Those rockets came from the USA, and it was at the USA where the first Indian rocket scientists were trained. And the ATS, Advanced Technology Satellite that I mentioned for the SITE program, where Arthur C. Clarke got a dish, well, that was also supported by the USA. India is member of, has signed the Outer Space Treaty. It does a lot of work for, participates in the UN's Interagency Debris Coordination Committee, minimize space debris. COSPAS-SARSAT, this space-based search and rescue. And there are a network of optical and radio telescopes which are designed to help with tracking from the surface of the Earth space debris, and India participates in that. And last year, the year before, India signed the Artemis Accords. So it's making use of all the options it gets in order to advance its own interests. Next slide, please. It's the last one, I think. What can we look forward to in 2035? This is a year that I picked up from something that the then ISRO chairman said. They should have the space station operational. They should have a higher launch cadence. They have announced recently an additional spaceport. Very early days. I remember them making the announcement about 4 years ago. They still haven't really started getting on with it. High throughput satellites. You know, ever since Starlink has been operational, other countries have said, no, we want one of this service for us as well. And just more recently, seeing what's happening in Ukraine, if in countries want that level of independence, they have to have access to their own services like this. So India is developing its own high throughput constellation of satellites to provide internet access. Developing it, space policy came out finally last year. On the back, that was the essential prerequisite for kickstarting the private space sector. Human spaceflight, Gaganyaan, as I said, is still coming along, very early days still, but they could turn it around fairly quickly. And then I mentioned Lupus, NISA, these collaborations with Japan and NASA still, and Artemis. There's a lot of opportunities for communication and for collaboration, and India likes to do that. And just the final word, why that works for India is because I think India is a democracy, this political system, one factor, which allows certainly NASA and most of the European Space Agency to collaborate with it very easily. And secondly, the English language. It's, you know, when I remember Rakesh Sharma told me that the hardest thing he had to do as part of his space training was to learn Russian. So today, I think if there are some youngsters listening, learn Chinese, because there is going to be a lot more collaboration with China, because China is really developing in pretty much every aspect of space, and it's something that hopefully India will at least keep trying to keep pace with. Throughout the Cold War, India remained non-aligned, didn't sign up to either USA or the USSR, and is still doing the same thing now because it serves its interests, like all countries do. Okay, that's the last slide, I think. Is there anything else?
Okay, right. Well, listen, Gurbir, thank you so much. That was incredibly interesting, and well, there was a lot I didn't know. So we'd like to thank you. Traditional fashion. Thank you so much, viewers. If you have any questions for Gurbir, then do please put them in the chat. And oh, good grief, Daz has popped up. How are you, Daz? He's all right. He's all right.
How are you? All right. How is everyone?
We're fine. We're fine. This is Gurbir. Daz Gurbir.
Fascinating talk. Fascinating talk, because we don't hear so much of the Indian Space Agency, and it was nice to have some in-depth knowledge to given to us today. It was really nice to actually listen to it. Thank you again. That was lovely.
Absolutely. Yeah, absolutely. And don't forget, the video about Chandrasekhar is on the Space Oddities channel. You can search for it easily enough. And we'd like to offer you our sincere thanks for that, Gurbir. Panel, do you have any questions for Gurbir? Anything you want to ask? I think that was so full of information.
Well, basically, and I think you did probably mention it, but and I know you're thinking they're rushing a bit too fast. But when do you think they will put actually a astronaut into space?
Well, I think the one of the things that they haven't mentioned, and they've been very quiet about, is this TDRIS satellite, which is an essential element for communication when human spacecraft are involved. So they keep saying, it's a bit like the NISAR launch. It should have happened last spring, then last summer, then last autumn, and it still hasn't taken off. So, and also I think it was a couple of years ago that India, because of the commercial imperative, launched 2 of its LVM-3s for, then it was called OneWeb, useful set nowadays, and because they got some income from it. It's a commercial launch. So some of these things do distract, and for legitimate reasons they have delays. But there's no, I think it's right now, before the end of next year is a realistic conclusion to make, I think, at this point.
Okay, thank you.
Fantastic. And viewers, if you would like to read Gurbir's book about the Indian space program, Gurbir has written several books, and they're all on Amazon. Here's the link for the book about the Indian space program. It's in the comments, so you can go to Amazon and look at it there, and hopefully buy it, of course. So there we are. So we'd like to say thank you. I mean, the history of the Indian space program is it's just one of dogged determination, isn't it? Really, making do on a tiny budget and persevering. But then, as you said, in the Indian constitution, it sort of commits Indians to following science and rationality and moving forward in that respect. So really, really interesting stuff. Oh God, I'm sorry that link to Gurbir's book was so long. That's a typical Amazon URL. It goes on forever. That's been one of the longest URLs of all time. Gurbir, you are more than welcome to stay with us for the rest of the show. We are going to go live to the splashdown in about 40 minutes, thereabouts. So you're welcome to stay with us for that. But otherwise, obviously, if you have other things to do, then we quite understand. So thank you so much for being here. And Gurbir, it's been lovely to actually meet you face to face after all these years.
And next week, actually, I will be in Spain, in Tenerife.
Lovely.
Miles from where you are. But hopefully we can meet up in person. And Michael, it's been a long time. I can chat with. I'm assuming the rest of you are all in the UK.
Yes. Whereabouts are you, Gurbir?
I'm just outside Manchester.
Okay. Nice. Yeah.
Right. Okay. Well, let's move on. We're going to go to the news now. Not a huge amount of news this week, but I will just go through this, and just give me a second to get myself set up here. And where is it? It's here. Okay. Right. So this is the news for this week. And the first one is a really lovely image from the James Webb Space Telescope. It's some exoplanets around the star HR 8799. And yes, you are actually looking at planets orbiting another star. taken with the James Webb Space Telescope, which, as you know, is an infrared telescope. And the different colors here represent different temperatures. And these are 4 gas giants, essentially. And what the James Webb has discovered is that they're probably forming, they're actually forming, they're still in the process of forming, because this is quite a young system. And they're forming like we think Jupiter and Saturn did. That is, you start with a core that accretes, and then the gravity of that pulls in gas from the solar nebula. And we can actually see these lovely gas giants forming. So they are, obviously they don't look that color to the naked eye. This is an infrared image. But if you want to know more about these exoplanets, don't forget that you've got Eyes on Exoplanets, which you can find on the NASA website, and it'll give you all the data about these planets and all the other exoplanets that we found. So do have a look at Eyes on Exoplanets at NASA, because you can keep up to date with all of these latest bits of information. Now, you may remember I talked a few weeks ago now, a good few weeks ago, about this threat to the European Southern Observatory Paranal site in Chile. As you know, Paranal gives us some of the world's best astronomy because it's under the darkest, clearest skies in the world. But now there's an application to build an industrial plant producing green hydrogen and ammonia. This is going to be a massive site. It's 300 hectares, would you believe? And it's just a few kilometers away from Paranal. Now, the update is that the Chilean government have looked at this, and they've said that the company behind it haven't met their environmental requirements, and they have actually basically lied about what they plan to do to mitigate the effects of light pollution. But the ESO has done a bit of a study, and they could lose between 35 and 50% of the work that they're able to do in these dark, clear skies. It could be a disaster for the whole site, not just Paranal, but for Europe's extremely large telescope that's under construction, and a few other instruments as well. So the Chilean government are investigating at the moment, and we'll just wait and see what happens. But this could be a disaster for one of the world's best observatories. It should not be allowed, obviously. So I just thought I'd show you that. Good news. This is another telescope that will be threatened by the same industrial development. This is the Vera Rubin Observatory, which is going to start observing later this year. And this week, the world's largest digital camera was installed on the telescope. Now, this digital camera is that's just the camera that's being installed in the telescope. It's a 3,200 megapixel camera, and it will be able to see a golf ball from 15 miles away, the telescope. So this is the level of precision we're talking about. And this week, as you can see, it was lifted into place and mounted on the telescope. And they are going to be doing the first test observations with the Vera Rubin telescope in a couple of months. The telescope is a survey telescope. It's going to photograph the entire southern hemisphere night sky every 3 nights over 10 years. And what it's going to be used for is to spot anything that changes in the night sky, like supernovae, asteroids, anything that moves or changes in the night sky, it will take note of. And it's going to be a revolutionary instrument that could discover a lot about the universe that bigger observatories don't see, because the Vera Rubin is a very wide-angle telescope, and that will be revolutionary. So that's good news to see that being installed after more than a decade in development. Lovely photo from Mars, the Hera spacecraft, which is on its way to observe the aftermath of the Dimorphos and Didymos system. We may remember this is the planetary defense experiment where NASA slammed a spacecraft into the asteroid to try and deflect it. In the first experiment protecting Earth from threatening asteroids, well, it did manage to change the orbit of the asteroid which orbits the larger one, and it did a fly past of Mars this week on its way out to the asteroid. And this is the Martian moon Deimos, photographed from here. We can actually just zoom in on that a bit. And this is Deimos. We've never really had clear photographs of Deimos for one reason or another. There's never been a spacecraft close enough to it. But I just thought I'd show you this as a lovely image of one of the two Martian moons, Phobos, of course, being the other one. Blue Ghost, you may have seen this in the news. Blue Ghost made history on the moon this week by taking the first ever image of a solar eclipse from the moon. So that is obviously the Earth obscuring the sun, and this was a sort of a diamond ring effect during the eclipse, and this was great news. A beautiful image. So Blue Ghost, as you may know, landed a couple of weeks ago. It has not been idle though. Let me show you what it's been up to. So one of the experiments is to fire 4 electrodes on wires at different directions from the lander, some distance away onto the lunar soil, and the electrodes are connected to a mast that had to be erected as well. The objective is that these 4 electrodes will basically have a look at the moon's crust and find out what's underneath the lander, basically. And this was when they actually did this. And if you look carefully, there goes one of the wires. And watch carefully. Here goes one of the electrodes, fired out of the lander with the wire trailing behind it. And then they erected the mast. There it goes. It's 8 feet tall. To join up all the wires and relay the information down to the lander. That's so that everything doesn't get tangled up. They needed to build a mast for that to support everything. Absolutely unbelievable images from Blue Ghost. And the last one is it's been doing a bit of drilling to analyze the lunar soil. This is an amazing piece of footage. The drill going into the lunar soil. Look at the sparks. And then there's a big sort of ejection of material there. And that drill is going to find out exactly what the lunar soil consists of and what's underneath it. So there we are. So that is that's the news for this week. And let me just get back to where I was. And it's been a really eventful week as far as exploration.
It was
goes.
really nice to see the camera on the Vera Rubin. I mean, we've been saying how big it is, but I think really we've underestimated how big it is. That's the size of an extended transit van. That was really large.
Yeah,
that
absolutely.
But it was excellent.
It's the size of a car. It's the size of a car.
Yeah, we thought it was sort of a large SUV, but that's the size of a transit van.
Yeah, definitely.
Yeah.
Also, the image of Deimos is stunning. Absolutely.
Stunning image of Deimos. Yeah, absolutely.
And
absolutely.
also with Blue Ghost, unfortunately, I think I saw today that it's officially gone dark.
Blue Ghost.
Yeah, Blue Ghost is officially gone dark now.
Well, yes, it was going to, wasn't it? Because it's been 2 weeks there.
And of course, it's coming into
night
time, so it can't
they don't expect it to survive.
it can't recharge its batteries because it's going into night time, going into the shade. But it's done some wonderful stuff, and I love the images of it just slinging those electrodes out into nowhere. It's and then the antenna on spring things that lances that just shot up and things like that. But yeah, it's it'd be interesting to see what science we get back from this. The drilling was fantastic. Now I'm just wondering whether or not that large all of a sudden outgassing or whatever it was deliberate, or was it did it hit a pocket of gas or something?
I don't know, to be quite honest.
It just seemed very strange that
it was like an explosion, wasn't it?
It was just boom, it was there. I don't know whether they shot some nitrogen down into there to clear the hole, or
I heard there was some gas within the drill itself.
Oh, yeah. So this is what I was trying.
I don't remember exactly why. So yeah.
Right. Oh, okay.
Yeah.
All right. Yeah. So anyway, we're going to move on now to Roger's bit, and Roger, as always, is ready with his night sky and the gallery. So you can take it away, Roger.
Okay, so here we go for the 18th to 24th of March, 2025. So we're coming almost up into the spring area of 2025. We're currently getting away from the full moon and working our way down through to the waning crescent. This was the day after the lunar eclipse, of which we will see some images later on. And so, through the night sky this week, we are still seeing Orion, although it is now rapidly setting towards the west. But we still have Jupiter at a reasonable height and Mars still visible. But as you can see from the eastern horizon, we are now getting galaxy season starting with Leo and Virgo now making their grand appearances into the southeastern skies. And also we're starting to see some signs of the summer triangle coming up soon. So be aware of all of that. So things are moving on. Obviously, we are just about coming up to the Messier Marathon at any time. So if you're interested in doing that, good luck. So before sunset, we have got Saturn ahead of the Sun, and Neptune just about disappeared into the brightness of it. Not that we could see it in daytime anyway. But we've also got Venus and Mercury still getting to see it in the evening skies, although to a lesser extent now. But there we go. But on the Sunday, on the 23rd, Saturn's rings will be edge on. So after that, well, they will start to open up again marginally. So that's all well and good. So there we go through the week of there. And just to give you a heads up for later on in the month, we have got a partial solar eclipse. And over in the UK, although we do get quite a lot less, we do get from Glasgow 41%, and down to Truro in Cornwall we get down to 36%. So still a reasonable bit of eclipse to see, and that will be quite interesting. But knowing the British weather, it will be cloudy, but who knows? So the peak will be, as we see on the slide here, about 10:38. But we do get to see it from about an hour or so before. So it's roughly about 4 hours from start to finish. So we hopefully should see at some point some part of the eclipse. Just another reminder of asteroid Flora. That will be heading over towards the Leo triplets later on in April. So just to keep your heads up on that. And that should be quite a good photo opportunity there. So that will be roughly anything between the 10th and the 12th of April. So just keep an eye out for that. Okay, so on to the gallery. And we do have a couple of images from Tom. And the first one is from the Elephant's Trunk Nebula, and 6 hours of imaging from him using PixInsight with his noise and blur exterminator. And there we go. Okay, the exterminator. So some nice details there. Well done. Very good. And then he also did an interesting study of trapezium, where he was trying to get some interesting details there. Some globules. Was it globules?
Oh, lovely.
So that was, yes, yeah, some proplyds, which he's highlighted there.
Yeah. Wow.
Yes.
Excellent.
Getting rather technical here, he is. And then we got another regular, Jerry, with M51 in Cainesville TC with his usual setup. And this is what he's managed to achieve with what he had. Very interesting.
Oh,
That's
Lots of
beautiful,
spiral details there. Yeah, lots of gas details there in the arms. Well done. Well done. Okay. And first of the lunar eclipse images from down in Cornwall land from Lee. He did manage to try and get a lot of it, but I think he had the same problem as me with those pesky clouds, but he was a bit more successful than I was. So this was the start of it. As you can see, the darkness starting to come over from the southeastern side of the moon, and a fully more developed lunar eclipse from further on. But unfortunately,
nice.
he didn't get too much more of that because the clouds come over. But he was more than lucky than what I managed to get. So well done to him. David Garside's got the Christmas tree cone nebula, and this was just taken over 3 hours on the 14th of March. And got some interesting details there. There's the cone over on the top right, with some of the other details further on to the left. Very nice. Some good details there. Okay, so this is my poor attempt at the lunar eclipse. Unfortunately, about an hour before the eclipse started, the clouds rolled in and I couldn't get any further than this image here. That's the maximum I managed to achieve with my visibility, unfortunately. It was perfect up to that point, and then UK weather. Thank you very much. Good night. And that will be the conclusion of this week's What's in the Night Sky with our gallery.
Fantastic. Thank you so much, Roger. That's absolutely brilliant. Yes. So indeed, let's get rid of that. Okay. So as time's getting on, we want to go to the splashdown soon. So what we're gonna do is we're going to leave Einstein of the Week until next week, and we'll have a bumper edition next week. So don't forget, if you have any, if you spot any, what am I trying to say? If you spot any funny things about astronomy or science that make you laugh, then do send them in an email to info@spaceoddities.space. So let's see some from you. Also, if you've got any photos of the eclipse that you took, doesn't matter how bad you think they are, we want to see them. So please send your eclipse photos and all of your astro images, as always, to gallery@spaceoddities.space. And we look forward to receiving them. If you could just restrict yourself to one image per email, please, and attach them to the email rather than pasting them into the email, that would be much appreciated, because it just makes life easier for poor old Roger there, who, let's face it, needs all the help he can get. So there we are. Okay, well, what we're going to do now, let's have a look at how things are going. How things are going with the splashdown. Oh, they're in the communications blackout. Oh, no, they're not. It's coming up, the communications blackout. In case you don't know, we're witnessing the return of Crew 9 to the Earth, carrying the two astronauts that have been stuck up there for 9 months when they only went on a 9-day mission. And there's been, as you know, there's been a lot of hype in the media about these astronauts being stranded in space. They were never stranded in space. It was just a scheduling issue. Of course, the initial problem arose because of the Boeing Starliner that took them up there developing problems, and they were unable to return to Earth on the Starliner. And it's just been a scheduling problem, nothing more. These are highly trained astronauts, and they are trained for long periods in space like this. And also, of course, if you read social media, excuse me, if you read social media, you might think that they're the two astronauts that have spent the longest time in space ever. Of course, they're not. There are astronauts who have spent over a year in space with no long-term ill effects. So, forget the hype. So we're going to go to the splashdown shortly, because it's now just under 11 minutes until these astronauts that have been on the ISS for 9 months come home. They do expect to be taken off the Dragon spacecraft on stretchers, but this is nothing to be alarmed about, because having been in microgravity for 9 months, of course, they are not used to Earth gravity again. So they do expect to be taken off in stretchers. They don't expect them to be able to get up and walk away. However, that's only a temporary thing, and it's nothing to worry about. We've seen this many times, particularly with the Russians, who hold the records for the longest time in space, over a year, and you always see them being carried away. And this is nothing new, but as I said, it is a temporary thing. It's nothing to get worried about. So, team, any comments, any thoughts before we go into this?
Well, it's been, well, as you know, for Sonny and Butch, it's been a long time coming. I still see the press insist on using words like stranded or abandoned or whatever. That they were never, not in the strictest sense, they were not stranded. They were not abandoned. Accommodation was made for them to be on the International Space Station. So they've always been safe. And it's just a shame that they insist on using such dramatic words to there's basically a lot of it's clickbait, but they've never been in any harm's way. So let's just get these people back. They will be relieved to get back. We'll be relieved to see them back. And of course, like I said, they were never abandoned, because with Crew 9 they only sent 2 astronauts up, so the accommodation for them to be brought back, it was already made. So they haven't been.
And there was
stranded,
always a spacecraft at the ISS for them to come back on.
Sorry, Andy, I missed that.
There was always a spacecraft at the ISS for them to come back on.
So it's not being so dramatic. It's
I know.
But it'd be nice to see him back.
I think a lot of that came from, sorry. I think a lot of that, especially in the minds of the American public, came from Trump, because he said, "Oh, I'm going to ask my best buddy Elon to go and rescue them." Well, SpaceX were always going to bring them down, because there was no, apart from the Russian Soyuz, which they were never going to use, SpaceX were always going to bring the astronauts back. And as I said, it was just a scheduling issue, nothing more.
And they resolved it within. Right, I see. Oh, sorry. I've just realised I haven't got the NASA site up, but on the NASA site, they've actually tracking now the it coming back through the.
Well, we can see where it is. It's over Central America at the moment.
They've actually started tracking it with cameras. It's actually a fireball at the moment. I'm surprised they haven't put it up on here.
Right, I've got that there as well.
Okay, can we switch to that?
Well, I'll have to come off of this and then.
Yeah, if you could, that'd be great.
Right, wait me a second. Just bear with me, please. I want the NASA one, don't I?
Yeah. So, I mean, I've seen some ridiculous things in the press about how it was the fault of the Biden administration, and the Biden administration left them up with the rot and things like this. It's all nonsense. It's absolute nonsense. It's just politicizing what is a normal occurrence with spaceflight, scheduling, and it was just one of those things. SpaceX actually caused some of this delay themselves, because they were sending up a new Dragon and it wasn't ready, so that delayed it by a couple of months. So there's so much nonsense being talked about.
But as you said, Andy, both Butch and Sonia have been trained as astronauts for years. They've both been in space for long periods of time, and they know. And the Starliner was a test flight. know what.
Yeah,
know
absolutely.
What, you know, I know you don't know what to expect from a test flight, but that's what it is, test flight, and it didn't complete, you know, the tests that it needed to. So, you know, yeah.
So there we are. There is the Dragon spacecraft. You're looking at an infrared image, which explains why it's glowing white. It's very hot.
And also, as it passed through the clouds, it disappeared in the clouds. That's when it flew over England. That's what we've got.
Oh, really?
Clouds. Yes.
Fantastic.
It's splashed down in the Gulf.
In the Gulf of Mexico.
I noticed yesterday when I was watching the when they separated from the International Space Station, NASA were hedging their bets. They referred to it as the Gulf of Mexico and the Gulf of America.
Oh,
So they're hedging their bets on this one.
right.
So, but we're not going to go into that. Don't want to talk about that. So yeah.
No,
perhaps not.
No, absolutely.
Yeah.
Oh, look, a UFO.
It does seem strange with all those rings around it, doesn't it?
Yeah.
But yeah, it's definitely coming through the atmosphere, though.
Yeah, definitely. Yep, that's amazing.
But there are, of course, 4 astronauts coming home.
Yeah.
So, you know.
Yes.
Because as you said, Michael, these are trained astronauts anyway, and they know what it's like. I mean, they've been to the International Space Station before.
Yeah.
So it's not that they didn't know what was coming in. It was just a case that they've had a longer stay. And truth be told, they'll have stories to tell, and they probably enjoyed their time to a certain degree. But they're coming home now, and I bet there'll be a bit. As Andy said, there probably will be need some aid to get off of here. They have been up there for quite a while now. Was it 8 months? Is it?
Yeah,
9 months. Okay, then. So yeah, they're going to be a little bit dizzy in that. Oh, there's some nice pictures coming in second. So oh, there go the drogue shoots. Sorry, I'm just watching it on another channel.
Oh,
We've got a bit of a delay on the.
That's so nice.
Here it comes.
Oh, wow! Look
It's
at that.
dropping like a stone.
What is it?
Yeah.
9.81 meters per second squared.
Yeah.
Hey, here we go.
Oh, look at that. That's a good shot.
Certainly is. And those chutes will open up in a second a little bit. So
Yeah.
you'll see them open a bit. And then, of course, we'll get the main chutes in a little while.
I wasn't sure whether there'd be some daylight left. It's good.
Yeah.
Wow, they're home nearly.
Yeah.
Okay, wait for the main chutes.
Here we go.
Oh, beautiful.
Yeah.
Oh, yes.
Here we go. Wow.
Here we go. There go the mains.
Ooh.
Size of those parachutes.
Yeah.
Well, they will be. Here we go.
Yeah. Here we go. 1, 2, 3. Oh, have they got a problem with one of them? No.
Almost
that's
there.
it.
Yeah.
Almost there.
They got some more of the messages written patterns on the top there again.
That's what I was looking at, the different patterns.
All right.
What is it? What do they say? Sorry.
Oh.
Must do better.
Yeah.
Boeing. No, sorry.
Yeah, blame Boeing.
SpaceX rules.
Yeah.
Yeah. Down with Boeing.
Yeah, there's some beautiful shots coming.
That slowed it right down.
That's beautiful.
Oh, we're just coming up to 5,000 feet.
Gosh.
You'll see a shot in a minute, and it looks like it's almost coming right down on the camera.
Yeah.
All right.
Oh,
Yeah.
that's an extended one.
Wow.
But I'm looking at it now.
Oh, yeah, there it is. Look at that.
On the head.
On the
Hard
side.
hats.
Over
Done
here.
your hard hats.
Yeah.
It's all CGI,
Oh, yeah.
of course.
Oh, yeah, of course.
Mm.
Of course.
Yeah.
Yeah. And there's definitely not a curvature on the edge of that ocean.
Because it's flat Earth.
Yeah.
Well, you put a spirit level on the ground, it stays in the middle. The Earth is flat. Yeah, that's a beautiful sight, though.
Ooh.
Oh, lovely sky as
Yeah.
well.
Mm.
Couldn't have a better day
Perfect.
for it, could
Yeah.
they? Or evening, or whatever the day is at the moment there.
Yeah.
It's
yeah,
going into early
Yes.
evening, isn't it?
It's
Yeah.
about-
So.
About 5. It's about coming out to 5 o'clock their time.
Up next, splashdown.
Yay.
That sea's really smooth for them, isn't it?
Mm.
Yeah.
It's a mill pond.
Yeah. Here he comes.
An American mill pond.
Well, I take it this is a drone shot that we're looking at.
Oh, yeah, probably.
Yeah,
So,
probably, yeah.
It's amazing how close we got.
That's
That is
brilliant.
beautiful.
Isn't it?
Mm.
That is just surreal. Sorry, I didn't mean to imply that it's not true.
Yeah.
Here we go. Here we go.
Ooh.
Hey.
Wow.
Hey!
You look at
They're
these
down.
next shots.
Hey. Wait, don't usually.
Butch and Sonny are home.
Yep.
Don't,
Here we are.
Yes.
It's writing itself.
Mm.
There we are.
don't usually see it this
Yeah.
close up.
No, exactly. This
No.
drone shot is absolutely fantastic. Needs a bit of a paint
Mm.
job, but I think we could reuse
yeah.
it.
Yeah,
Oh, that'll
again.
scrape off.
Yeah,
Mhm.
jobs are good.
Wow. Mm. Wow. Magic. Oh, it's coming
Fantastic.
towards the capsule.
Oh yeah, look at those
Yeah, you can
high-speed
see them
boats
coming
coming.
in.
yeah.
And of course, they retrieve
Oh,
the
that is
parachutes as well. So
Yes, of course.
nout wasted on this. So, well, that was a fantastic splashdown. Welcome back,
think,
Sonny and Butch.
Yay.
Welcome back, Sonny. Do you think Elon had a word with NASA and said, "Have you ever considered using drones for your life footage?"
Mm. SpaceX drones, of course.
Well, actually, this is actually, I think it is actually SpaceX
Yeah, probably is actually.
footage, and
Yeah.
NASA broadcasted it.
Yeah.
So anyway, it's been a while for them. They're probably already feeling the weight of gravity on their chest and all that. So after all that time in space, but fair play to them. They're back now, so just got to wait about sort of like a few minutes, about a half hour. Because this is so fast when they do this. They're so proficient that they next to no time it's back on the ship. They get in the hatch open and they're in there and they're helping the astronauts egress. So
Saying, yeah, egress, not leave. Egress.
Mm.
Oh, it's water pouring out of it.
Mm.
I think that's venting
Is that
any of
venting?
the fluid
Yeah.
things on there. So
Yeah.
with that, or they've got a leak and they're pumping like bugger.
Or somebody's having a wee.
It's been holding on to that for 9 months. But no, it's. I'm surprised that I know there's such a certain large surface area, but I'm surprised that the parachutes don't actually sink. They just seem to sit on the top so they can be recovered. So maybe it's the material they're made of. I don't know, but
Perhaps they got something around the edges of the
could
it to keep it afloat.
Yeah, some little polystyrene balls or something. I don't know.
Do we know if they actually reuse the parachutes? Are they?
I don't know. I was
refurbished
just
and used
thinking that
again?
myself. But
Don't see why they shouldn't.
no.
Yeah, because they're expensive things.
Yeah.
Yes.
Here come the boats.
Yeah. Hurry up.
Fantastic.
Yeah. Because 2 of the boats will recover the parachutes, and then the 3rd will actually approach the capsule. They use a sniffer on a long pole, on the end of a broom handle or something. Very technical. Just to sniff, just to make sure there's no volatiles left around or any engine fuel escaping. So they won't go straight in. So see, look that broom handle. With a little sniffer on the end.
Yeah.
So we'll make sure everything's safe.
Yes, because if there's any hydrogen vapor left in the air, that's incredibly toxic. So they do need to make sure that it's safe before they put anybody aboard.
So yeah, fantastic. A good result all round on that one. So yeah, welcome back.
Yeah. So they're just basically sniffing the capsule to make sure that there are no toxic gases before they put the guy aboard to secure the capsule. I mean, that sea is God, I could really just dive in that sea at the moment. That would be beautiful. Look how still it is.
Oh, it certainly is. It's ideal for them, isn't it?
Yep.
Yeah, it's perfect for them.
Makes life so much easier.
Yeah.
So they're just still checking. There's no escaping gases or fuel or anything. So
backing off a little bit. I hope they haven't.
They're probably just repositioning, hopefully.
Yeah. And they are wearing respirators, so they should be all right. It's just a precaution because it doesn't normally happen.
Right, I can remember the very first time they recovered one of these capsules, it took hours before they even got it on board because they were so checking everything. And even when it came on board, they again sniffed it and used sensors and everything, all that. And it was a long process. But now, these days, I mean, as you can see, the recovery ship is almost there now. So that comes in as well. And within, like 40-45 minutes, they're usually on board. So, yeah, it's they've got this down pat. They really know what's going on. Because I noticed actually they haven't actually recovered the parachutes. They put buoys on them, so that's, I suppose, to also help stop them sinking.
Oh, those poor boys! Did they volunteer?
Well, job creation, isn't it?
Yeah.
So
true.
Right then, guys, I'm going to have to leave you. So
okay then. See you later, Michael. Take care.
All right. Well, I think we will call things to a close for today because it will be quite a while before they get back on the ship and they're open the hatch. This could be, could be an hour or more. So I think we would draw things to a close for today, viewers. Thank you so much for being with us. We'd like to give a big thank you to Gurbir for his absolutely fascinating talk about the Indian space program. Very, very interesting indeed. And Gurbir, I don't know if he's still here. No, he's not. But I will thank him on your behalf, viewers, because really interesting information about where India's been in space, where it's going, and a lot of the history I wasn't aware of. So really interesting. So thank you so much to Gurbir for being with us tonight. Don't forget, in April, it's Moon Month on Space Oddities. We're devoting a lot of time in April to everything to do with the moon. We've got, at the moment, I think about 20 videos lined up to show on the channel about the moon during April. We'll also be talking about it on our Tuesday live streams, and we hope you will join us during April. Keep your eye on the channel, because that's where we'll be posting a lot of the stuff. Of course, if you're subscribed to the channel, which obviously we hope you are, then click the notification bell and you'll get to know all about our postings, as it were, on the channel. But we're looking forward to Moon Month, and especially this year with the lunar eclipse going on, and both IM2 RIP and Blue Ghost, probably our RIP, having gone to the moon, and it's really the year of the moon. So we thought we would commemorate that by having a whole month about the moon. So we're covering everything about the moon, from its formation and evolution. We're covering, I think, just about all the missions that have ever been to the moon, manned and unmanned. We're going to tell you about water on the moon. We're going to tell you about future plans for the moon. We're going to tell you everything that we possibly can about the moon in April. So we hope that you will send your photos of the moon into the gallery, particularly the eclipse. And as always, send your images to gallery@spaceoddities.space. So we'd like to say a good evening to you. We'll be back next week. Not quite sure what we've got organized for next week yet, but we'll put something together for you before then, obviously. And then, as I said, in April, it's Moon Month. So thank you for your support, viewers. Thank you so much for your donations this evening. Those of you who've donated in order to keep the channel running, much appreciated. We do appreciate every bit of money that we receive, because it enables us to keep Space Oddities going. Space Oddities is fast approaching its 3rd anniversary, would you believe? That will be late in May, last week of May. That will be our 3rd anniversary. We'll no doubt do something special for that. But thank you for sticking with us for nearly 3 years
3rd
now.
anniversary.
Those of you that have. Yeah. Well, yeah, absolutely. So yes, it'll be about another, Ian's just said it'll be about another 40-45 minutes before they egress from the Dragon. And there's a sentence I never thought I'd say. So we will say goodnight for now. Of course, you can follow the rest of this on the NASA channel on YouTube. But from all of us, from Daz, myself, from Roger, I would like to wish you a very good evening, and we will see you same time, 8 p.m. UK, next week here on Space Oddities. But thank you for being here, and good evening.